Ladles and jelly spoons, welcome back to Badgerworks. Today, this. Now, you may remember from a previous video, this is the static grass applicator that I made. It's worked very well. I've used it in a couple of projects, as you've seen, but it needs a bit of an upgrade. Or, well, not an upgrade, I'm going to make a new one. A very dear friend of mine who's into model railways has asked me to make one of these for him, but on a slightly larger scale. He works on slightly bigger dioramas than I do. So that's what we're going to do. So let's get on with it. Now what we're going to do with this one, it's going to be on a slightly more industrial scale, shall we say. To give you an idea of what I'm talking about, this is the static generator from the first one that we made. It's 12 volts, or 12 volt in and 6 kilovolts out, 6,000 volts. This is the one we're going to use today. Slightly larger, as you can see. This is still 12 volts, but the output on this is 20 kilovolts, 20,000 volts. It's actually adjustable. You'll see there's a potentiometer there. I don't know if you can see that or not. But there's a potentiometer. You can actually adjust this from between 15 and 20 kilovolts. So we're going to use this one to give us a bit more oomph. Now, a few other changes that we're going to make, which I shall show you. On the previous model, we used one of these sample tube for our applicator. Today we're going to use this. It's a plastic tub. You can get 3 of them for £1 from Asda, or Pound Shop or anywhere really. So as you can see, it's a little bit bigger. It's still not particularly deep, but it will hold a lot more than this, and it will also have a much greater area for the grass to come out. So that's our container. The other thing I'm going to change is the mesh. So this is what I'm going to use for mesh. These also came from Asda. I think these are about £2.50 for the pair. They're stainless steel tea strainers. So they're quite a fine mesh, so they should work quite nicely for what we're going to do. Now, I don't know if you remember on the previous video, the mesh I used there claimed to be stainless steel, but clearly wasn't. And this is actually a good time to show you the difference. So let me get a bit I've already cut. So this is the mesh we used originally. You can see it's quite dull, it doesn't have much luster to it. And this is the mesh from the new one. Now the first thing you'll notice is this mesh is much finer. The hole size are about the same, but the actual mesh is much finer. Also, you can see the difference in the colour. And you can also see this one catches the light a lot more. This is actually stainless steel. What makes stainless steel stainless is that it has a high, or relatively high, chrome content. Chrome doesn't rust or resists oxidization much better than steel. So by adding chrome to the steel, it makes it much more rust resistant. So yeah, this is stainless steel. This, I'm not sure what this is, but it's not stainless steel. I would hazard a guess that it's perhaps aluminium. It's very soft. But anyway, this is what we're going to be using today. So this is basically come out of one of those tea strainers. Now, on to the actual design itself. As far as the basic design goes, it's going to be the same as this one, with a couple of minor differences. This is a new handle that I've cut. You'll notice that it's actually longer than the old one, and the reason for that is very simple. This does not fit inside the tube. So what I'm going to do is I'm actually going to bolt it to the outside. It's perfectly safe. It's plastic. Plastic is non-conductive. This is the dangerous end. So I'll cut a couple of holes in the pipe, feed the wire through, and bolt this to the outside of the tube. It's still not, it actually makes it a bit easier to get hold of. As far as that goes, that's the only real major change. We're going to use the end caps the same as we did before. We'll have to change the mounting of the pot slightly, because obviously this one is I drilled a hole in the end cap and put the tube inside it. Obviously with this one it's a little bit different. So what I'll do here is I'll take the end cap and I'll actually bolt it on. I'll put a couple of bolts through it, and then drill a hole through the middle for the wire to go through both. And then aside from that, the construction is exactly the same. So let's get on with it, shall we? So I'm just going to mark the rough position of where the holes need to go for this and where I need to cut the holes for the wires to go. The reason I've got the end cap on is I've worked out that the live wire should be just about long enough to reach the cap where it needs to be connected to the mesh without having to extend it. But in order to give myself the best possible chance, I'm going to mount this as far down the tube as it will go. So I want to have the end cap on so that I can mark this hole, and I know that this mounting eyelet won't interfere with the hole, with the end cap. So if I just put that there, and I can mark one hole there, mark the other hole there, and I don't know if you'll be able to see those marks very well. I can see them, but the camera probably won't pick them up very well. But now I can drill some holes, mounting holes, and I can measure from those holes to cut the holes for the wires to go through. Now for the lid of our pot, obviously we need to cut a hole in it for the mesh to go in. I'm going to cut this out on the drill press using a hole saw, simply because it's easier for me to do it that way. But you can cut it with a Dremel or a hobby knife or anything like that. Obviously, as with anything, when you're cutting something, mind your fingers, because you don't want to lose a finger over something like this. So I'll take this and drill this one out as well. So I've just started bolting the box to the handle, and the bolts I'm using are 4mm hex bolts. And on the inside I'm using a nylock nut. Now this has, I don't know if you can see that very well, focus. Inside you'll see there's a little blue plastic ring, and basically what that does is it grips the thread and it stops the nut backing off, which means that they won't come loose inside, because the last thing you want to be doing is tightening these nuts up every 5 minutes. So I'll just put this one in and then we'll get on with the rest of it. So here's the box bolted to the handle. The live wire runs down the middle, which will go to the mesh. The negative goes outside, it will have a clip on the end of it. Now we can put the end cap on. To attach the cup to the base, I'm using these 4mm machine screws. So I'll just put a washer on there. I'm not going to put a washer on the inside because it doesn't need it. I'll make sure I get these holes lined up. Yeah, that's right. And again, I'm using a nylock screw, a nylock nut rather, for the inside. So I'll just put the 3 of them in, and then a little hint when you're doing anything up like this: put all the fittings in before you start tightening anything up, because if you tighten one up and the holes aren't lined up properly, it'll all bind up and you'll never be able to get it together. I'll tighten those up. And there's the cap nicely secured. Now again, I've used the nylock nuts here because once this is all fitted together, you're never going to be, well, you could get to these, but it'd be very, very difficult. It'd be like redecorating your house through the letterbox. So by using the nylock nuts, there's no chance of them coming loose in the future. So now we can thread the live wire through the middle and glue the cap onto the handle. So that's the cap fitted. I haven't glued it on yet, but I just wanted to show you that there is enough wire there so that once this is soldered to the mesh, there'll still be enough room, plenty of room to get inside to put more grass in. Okay, so what we need to do now is cut the mesh out from our tea strainer. The easiest way to do this is to take a blade of some sort and just push it through. Obviously, as with anything with a knife, mind your fingers. Just make a hole and then take a decent pair of scissors and cut it out. I should mention that when I say a decent pair of scissors, they won't stay decent for very long, but it will do for what we want to do. And we just go round, try and keep as close to the edge as you can. Once you get going, it actually gets a lot easier to keep the scissors flat to the edge, because basically the only reason is we want to salvage as much of this mesh as we can. So, and there we go. Now we take our lid, and what we want to do is, the mesh is actually not bad, it's almost exactly the right size. We just need to cut it down a little bit so that it will fit inside. So the easiest way to do that is to lay the mesh down, put the lid on top of it and kind of center it as best you can. Then we take a dry white marker and just go round the inside like this. And now we can take our scissors, and as long as we cut on the outside of that hole, leave us a fair bit around the edge, it should fit quite nicely. So, and there we go. That's actually come out a really good fit. So what I'm going to do now is glue it in. So to fix the mesh to the lid, I'm going to use this. This is Unibond epoxy. I normally use Aerodite, but the reason I'm going to use this one is because it actually mixes it in the tube. So the idea being is that I can put this on and just put a bead around here in one swift movement and not have to mess about too much. Plus the fact apparently it's supposed to set in 1 minute, which is quite handy. Now before I apply the glue, there's a couple of bits I wanted to talk about with this. This is actually fitting quite nicely, but they won't always fit as nicely as that. So I've got another one here because I'm actually making 2 of these. So this is the lid for the other one, and this one is not quite as well fitting. So what you can do to make them fit better is just bend the edges down slightly all the way around, and then drop it in. I don't know whether you're going to be able to see this, but basically when you push the middle down, it then holds quite nicely all the way round. And then what you can do is just drop it down, pop a suitable bit of ballast in the middle, and now it's holding the edges down quite nicely, and we can glue it again. So let's give it a go and see how we get on. Right, now apparently what you're supposed to do with this is put the applicator on and twist it to lock it in place. Oh yeah, like that. And then squeeze, and basically what it does, I don't know if you can see it very well, there's like a helix in there, and as the 2 parts go in, they go round the helix and get mixed. That's why this nozzle is so long, and basically so by the time it gets to the end, it's fully mixed. So let's see how well this works. Oh, here we go. Oh yeah, there it goes. I don't know if you can see that going up the tube, but it's actually mixing it as it goes through the tube. So push it all the way to the end. Now let's pull that back a bit. Now we can just set that one aside and hope for the best. Alright, let's get the other one in. I think what I'm going to do with this one is I'm going to put the bead around the inside first and then drop this into it. Back to one side. Now we drop that into the adhesive like so. Put a bit of weight in the middle of it to hold it in place. Wow, this stuff sets really, really fast. When they said a minute, they weren't kidding. This is actually gelled already. It was almost before I had a chance to get all the way round, it had set up. Wow, that's really fast drying. Yeah, this one's pretty much cured already. Right, so we'll just give these, the instructions say give it half an hour, but I mean we'll leave them for now. I've no need to use them just this minute. We'll set these aside until they're fully cured, and then we'll be pretty much done. Okay, now for the fun bit. I'm going to try and solder the wire to the mesh. Right, that seemed to go surprisingly well. Let's have a look at the underside. Oh, that's actually worked quite well. Quite pleased with that. I'll just nip the end off here. Alright, that seems very secure on there, that's nice. So this is it pretty much finished now. All we've got to do now is test it. Okay, so here's the thing in all its glory. One minor change in this, I've put the power switch on the side, and that's basically so when you're holding it, it's easier to get to the power switch. But other than that, the wiring and inside is everything is exactly the same as the last video. So let's give it a little poke and see if it works. So the power light's on, so we know it's working. Now, who wants to see what 20,000 volts looks like? Ready? Contact. Yep, I'd say that's a successful test. You can actually feel the static field around this thing when you switch it on. It makes the hairs on your arms stand up. Yeah, I think 20,000 volts is going to work really nicely. So the next thing to do is put some grass in the thing and see how it works. So what I've got here is a little board with some filler on it. I use this as a test for something else. I've just put some brown paint on it quickly, and I've got a little bit of greaseproof paper. And what I'm going to do is I'm going to try and coat this with the static grass and make some tufts. I've got some PVA here, and I'll just put some blobs like that, and I'll put some on here, just roughly like that. Now we'll load up the applicator. Now what I've got in here is a mixture of 2, 4 and 6 millimeter meadow grass. So let's fire it up and see what happens. Wow, that's working really nicely. Yeah, that has worked really, really well. Just as a quick aside, I've had a couple of people mention to me after watching the previous video, why did I not put a battery in to make the thing portable? And the simple fact of the matter is I don't need to. I've got quite a prolific collection of these. These are lithium-ion 12-volt batteries, and they have the same 5.5 by 2.5 mil connector that I use for everything. So if I want to use the thing portable, as it were, I just plug one of these in. I did a whole video on these batteries. I'll put a link to it, but yeah, just a little side note. So yeah, as you can see, this has worked really well. I'm very, very happy with the way this has turned out. Obviously the smaller one is still very useful, but this is great for doing larger areas. So yeah, I can see there's going to be quite a lot of use for this in the future. So yeah, I hope this has been of interest to you. It's certainly going to be very useful for me. Thanks very much for watching, and I'll see you on the next video. Cheers, bye.